Here we're asked to solve a nonlinear system. Let's solve this using the substitution method. And so the first step would be to isolate one of the variables here. In this case, I'm going to isolate y and write x minus 5 equals y. Now, I'll take x minus 5 and substitute that into the other equation for y. And that leaves us with x squared plus y, which I'm going to use x minus 5, plus 1, that whole quantity squared, equals 8. Now once we substitute x minus 5 in for y, there's only one variable left, and we can solve for that. And so here we have x squared plus x minus 4 squared equals 8, or x squared plus x squared minus 8x plus 16 equals 8. 2x squared minus 8x plus 16 equals 8. Now this is quadratic, so we need to get this equal to 0. And so to do that, we'll subtract 8 on both sides. And we have standard form here, 2x squared minus 8x plus 8 equals 0. Now I'm going to try to factor this, but first I notice that there is a GCF. So let's go ahead and factor that out. Factoring out a 2, we're left with x squared minus 4x plus 4. And sure enough, that does factor. And so we have x and x, 4 factors as 2 times 2, and 2x adds up to negative 4x if they're both negative here. Okay, and then setting each factor equal to 0, we can see, well, each variable factor equal to 0. You could see we get x equals 2 as a solution occurring twice. So really there's only one solution to this. Now to find the corresponding y value, we have to then back substitute. And I'll go ahead and back substitute into this equation. We have y equals x minus 5, and we know x is 2, so we'll write 2 minus 5. In other words, y equals negative 3. Okay, so the answer here should be presented as an ordered pair, x comma y. So this system has a common or a simultaneous solution at 2 comma negative 3.